Good morning, students. In our last class, we have done some questions based on trigonometric functions, and I have given 10 questions. From the 10 questions, most of the students have doubts from question number 4 to 10. So, one by one, I will do now. So, here I have written two questions, question number 4 and 5. In the question number 4, it is given that we have to show that cosec x multiplied to sec x minus 1 minus cot x multiplied to 1 minus cos x is equal to tan x minus sin x. So, in different ways you can do this one. I will consider LHS and I will write the whole expression in the form of sin and cos. So I will start question number 4, right? So, solution. At first we have to consider the left hand side, and in the left hand side it is given cosec x multiplied to sec x minus 1 minus cot x multiplied to 1 minus cos x. So, here we can write this is 1 upon sin x, because we know that sin x multiplied to cosec x is equal to 1, that is why cosec x is equal to 1 divided by sin x, right. So, here sec x, this is 1 upon cos x, this is minus 1. Here we can write this is cos x divided by sin x, because we know the formula cot x is equal to cos x divided by sin x. So, clearly this is 1 minus cos x, right. So, here what we will write, see here. So, this is equal to 1 by sin x multiplied to, if we will take LCM, so clearly it is cos x and the expression will be 1 minus cos x divided by cos x only. Similarly, here this will be cos x multiplied to 1 minus cos x divided by sin x only, right. So, what is our requirement? So, our requirement is tan x minus sin x, right. So, here what we will do, our requirement tan x minus sin x. So, here see that what is common, 1 minus cos x is common, here 1 by sin x is also common. So, I will take 1 by sin x is common, so that what happens here, see here. So, this will become 1 minus cos x, 1 minus cos x by cos x minus, clearly it will be cos x multiplied to 1 minus cos x, right. Otherwise, directly we can take LCM, that is sin x into cos x also, we can do like that only. So, here we will get 1 divided by sin x, and what is LCM here? So, LCM will be cos x, so clearly this is 1 minus cos x, this is minus cos square x, right, into one minus cos x whole divided by cos x, right. So clearly what we got here, see that here outside the bracket we have 1 by sin x. See here this is one term 1 minus cos x, here is another term 1 minus cos x. So I can take 1 minus cos x as common, right? So within the bracket I will take 1 minus cos x as common, and here we will get 1 minus cos square x, right? See that, divided by how much? Here is cos x. See here what I did here, I have taken 1 minus cos x as common. Otherwise directly from here also you can take 1 by sin x, 1 minus cos x. 1 minus cos x divided by sin x you can directly take common, so that it will become 1 by cos x minus cos x. So 1 minus cos square x by cos x will get. So here this will become 1 by sin x, right? 1 by sin x. Clearly it is 1 minus cos x multiplied to, clearly from the formula we know 1 minus cos square x is equal to how much? Sin square x divided by cos x, right? So that, see here here sin x is present, here sin x is present, so we can cancel 1 sin x, right? So what is remaining? So the remaining is 1 minus cos x divided by, here cos x is present, right, and 1 sin x will be present. So see that this sin x by cos x is equal to how much? Otherwise I will multiply sin x, right, to the numerator. So clearly this will be sin x minus into cos x divided by cos x. If you have good understanding, then directly you can write, right? So if we will separate this one, sin x by cos x, we got what? Sin x by cos x, right, minus sin x cos x divided by cos x, so clearly it is sin x. So we got, this is tan x minus sin x, which is nothing but our RHS. This is the proof of the question number 4. Here you can reduce the number of steps, like see here in the third step I have taken only 1 by sin x common. You can take 1 minus cos x, 1 minus cos x divided by sin x directly as common. Likewise, see here, here in the third step directly you can write 1 minus cos x divided by sin x, and you will get what? 1 by cos x minus cos x, 1 by cos x minus cos x, right? So here you will get this one directly, this particular step, right? You will directly come to this particular step. So here 1 minus cos square by cos x, right? So directly you will come to this particular step. From here also you can take 1 minus cos x by sin x common, right? So clearly we have proved this question. What we did here, at first we have converted all the expressions in the form of sin cos. After that we have taken 1 by sin x common. Otherwise you can directly take 1 minus cos x by sin x as common like this. After that take LCM as cos x, it will become 1 minus cos square x by cos x, then multiply, and you have to apply 1 minus cos square x is equal to sin square, then sin cancelled, one sin is present, so clearly sin by cos will become 10. Directly you can multiply to 1 minus cos x also, so that 10 into 1 10x, cos multiplied to 10, that is sin, directly will get. Here I have written in detail, right? So clearly we got the right hand side, that is a 10x minus sin x. So this is the proof of question number 4. So we will go for question number 5. So at first we have to consider the left hand side, right? So what is the left hand side? So in the left hand side it is given 1 minus sin x into cos x divided by cos x multiplied to, here is sec x minus cosec x. This is again multiplied to sin square x minus cos square x divided by cube x plus cos cube x. See here, we have to show that this expression is equal to sin x. So see here almost all the terms are in the form of sin cos, but here see that this is sec x and this is cosec x. So at first I will write in the place of sec x as 1 by cos and here 1 by sin, right? After that we will do some more simplification, right? So this is 1 minus sin x multiplied to cos x divided by, this is what, cos x. Here what happens, see that this will be 1 by cos x minus, this is 1 by how much, sin x, because we know the formula sec x is equal to 1 by cos x, cosec x is equal to 1 by sin x. And see here, in this particular expression, in the numerator we have sin square x minus cos square x. See that it is of the form a square minus b square. So I can apply, this is equal to sin x plus cos x multiplied to sin x minus cos x, right? So here I have applied a square minus b square is equal to a plus b multiplied to a minus b formula, right? Similarly, see here the expression is sin cube x plus cos cube x. This is of the form a cube plus b cube. So we have to apply a cube plus b cube formula. So what is the formula? See here, this is equal to sin x plus cos x. A cube plus b cube is equal to a plus b multiplied to a square, that is here sin square x, right, plus b square, that is cos square x, minus ab. So clearly it is sin x into cos x, right? So after that what we have to do, this is 1 minus sin x into cos x divided by, here cos x is present, and here what is the LCM? Clearly LCM is sin x into cos x, right? This is sin x into cos x, so that it will become what, sin x minus cos x. See here, we have applied the formula over here, a square minus b square, a cube plus b cube. Clearly this term and this term cancel out. So what is remaining here? Remaining is sin x minus cos x divided by, here in the place of sin square x plus cos, otherwise we will write in the next step. First write this is sin square x plus cos square x minus sin x into cos x. So that, see here, this cos x and this cos x will cancel out and this sin will go to the numerator, right? So what happens here, this is equal to, this sin will go to the numerator, so we have sin x multiplied to 1 minus sin x into cos x divided by sin x minus cos x divided by minus cos x, right? Multiply to, we have the term sin x minus cos x divided by, here sin square x plus cos square x, clearly we know that this is 1, right, minus sin x into cos x, right? So see here, the term 1 minus sin x into cos x will cancel with this term and sin x minus cos x will cancel with this term, so we will get sin x. This is nothing but the RHS. So see here, we have just converted this sec x and cosec x in the form of sin cos, that is sec x as 1 by cos, cosec x as 1 by sin, and we have applied a square minus b square formula as well as aq plus bq formula, so that after some simplification clearly we got this expression is equal to sin x. So this is all about question number 4 and 5. Next we will do question number 6 and 7. So in the question number 6 it is given, we have to show that tan x divided by 1 minus cot x plus cot x divided by 1 minus tan x is equal to sec x cosec x plus 1. That means, see here, what is our requirement? Our requirement is sec x into cos x, that means 1 by cos x 1 by sin x. That is, if we will get 1 divided by sin x into cos x plus 1, then our proof is over, right? So we will try to find out 1 divided by sin x cos x plus 1, right? So so question number 6, LHS. What is the left hand side? Left hand side is tan x divided by 1 minus cot x plus cot x divided by 1 minus tan x. So our requirement is, we have to find sec x, we have to find sec x multiplied to cosec x plus 1. This is our requirement. So what I will do here, I will convert each and every term in the form of sin cos. So tan x can be written as sin x by cos x divided by, this is 1 minus cos x by sin x, right? Plus similarly here cot x is equal to cos x by sin x whole divided by, this is 1 minus sin x by cos x. So this can be written as, clearly this is sin x by cos x. In the denominator, what is the LCM? Sin x. So clearly this will be sin x minus cos x divided by sin x, right? Similarly here, what is the requirement? This is cos x by sin x. Here what is our LCM? Cos x, so clearly it will be cos x minus sin x by cos x. See here, what I did here, in the denominator I have taken sin x as LCM, so clearly this is sin x minus cos x whole divided by sin x. If we will separate this one, we will get this one, right? Similarly here also I have taken LCM as cos x, so clearly cos x minus sin x, right? So this particular term will go to the numerator and this cos x will go to the numerator, right? So this will be is equal to, right, this is equal to clearly sin square x. This will become what? Sin x by cos x multiplied to sin x divided by this one. So clearly this will be sin square x divided by cos x multiplied to sin x minus cos x, right? Similarly, this particular term will become, this is equal to cos square x divided by, this will be sin x multiplied to cos x minus sin x, right? So here see that here we have sin x minus cos x, here cos x minus sin x. So I will take minus common and this will be multiplied here and it will become minus. So clearly this will be sin square x divided by cos x multiplied to sin x minus cos x, and this will be minus cos square x divided by sin x multiplied to, here this will be sin x minus cos x. What is the reason? I have taken minus common and that minus will be multiplied here and it will become what? Minus. Now I will take LCM here. So what is LCM? Here this term is common, sin x minus cos x, so clearly this is the part of LCM, and again there are two different terms, that is sin x into cos x. So the LCM is sin x into cos x multiplied to sin x minus cos x. So this is our LCM, right? So clearly we will divide this particular term by this one. So what is remaining? Sin x, and that sin x will multiply here. So clearly this will be sin cube x minus, clearly we will divide this particular term with this one. So what is remaining? Cos. So this will be cos cube x, right? Now what we have to do? We have to apply a cube minus b cube formula in the numerator. So what is the formula? That is a minus b, that is sin x minus cos x, right, multiplied to a square plus b square plus ab, right? So this is sin square x plus cos square x plus sin x multiplied to cos x whole divided by, this is sin x into cos x, right, multiplied to sin x minus cos x. See here, this term multiplied to this whole term, divided by this one multiplied to this one. So clearly cos x, not cos x, that is sin x minus cos x, sin x minus cos x will cancel out. So what is remaining in the numerator? In the numerator we will get sin square x plus cos square x. I will directly put it is 1 plus sin x into cos x divided by, clearly this is sin x into cos x, right? Now we will write separately, that is 1 divided by, this will be 1 divided by sin x into cos x plus 1. So this can be written like this, 1 by, as per our requirement I will write 1 by sin x. Clearly if we will multiply, this will become 1 divided by sin x into cos x plus 1. So clearly this is sec x multiplied to cosec x plus 1. This is nothing but our RHS. So here we have proved that this particular expression is equal to sec x multiplied to cosec x plus 1. Just here I have used, first of all I have converted tan cot in the form of sin cos, and just I have used AQ minus BQ formula, that's it, and we will got the result. Similarly we will go for the second question, that is the question number 7. Here we have to use AQ plus BQ formula, and here AQ minus BQ formula, and we will obtain the required result, that is 2. Now I will do the question number 7. So what is the LHS? Left hand side, clearly this is sin cube x plus cos cube x divided by sin x plus cos x plus, here another term is sin cube x minus cos cube x divided by minus cos x, and our requirement is 2, that is our right hand side. So here I will apply AQ plus BQ formula. So what is the formula? So this is equal to A plus B, that is sin x plus cos x, right? So AQ plus BQ formula, at first A plus B multiplied to A square, that is sin square x plus B square cos square x minus AB, that is sin x into cos x, whole divided by how much? Here is sin x plus cos x, right? So this term is equal to this particular term, right? Similarly we will go for the second term. Again in this particular term we have to apply AQ minus BQ formula. So what is the formula? First of all A minus B, that is sin x minus cos x, A minus B, then A square. So this is sin square x plus B square, that is cos square x, then plus AB, right? So this will be sin x into cos x divided by sin x minus cos x. Cos x. So see that here we have sin x plus cos x, in the denominator also sin x plus cos x. So clearly these two terms will cancel out. Similarly here also these two terms will cancel out, right? So what is remaining? The remaining is sin square x plus cos square x plus, not plus here, minus is present, minus sin x into cos x, then plus, what is remaining here also, sin square x plus cos square x minus, not minus here, plus, right, plus sin x into cos x. See here, this is minus sin x into cos x, this is plus sin x to cos x, these two terms will cancel out, right. We know that sin square x plus cos square x formula we have, what is the value, this is 1 plus again this sin square x plus cos square x, that is also 1. So clearly this is 2, this is our right hand side, right. So just apply the formula AQ plus BQ as well as AQ minus BQ. So clearly we will get the result, that is 2. This is all about question number 6 and 7. Next we will go for these 3 questions. In the first question, see that in the question number 8, sec x sec y plus tan x tan y whole square minus sec x tan y plus tan x sec y whole square is equal to 1. So we have to take LHS and we have to show that this is equal to 1. You can apply a square minus b square formula. Otherwise, we can apply a plus b whole square. Here also a plus b whole square, right? So we will go for question number 8. So I have to consider left hand side, right? So what is LHS? Sec x sec y plus tan x tan y whole square minus sec x tan y plus tan x sec y whole square, right. Here I will apply a plus b whole square formula. So clearly see that this is sec x into sec y whole square plus tan x tan y whole square plus 2ab, that is equal to 2 sec x sec y into tan x tan y. So for the first term I have applied a plus b whole square, that is a square plus b square plus 2a into b, right, minus, we will put a bracket here because minus is present, right, again a plus b whole square. So I will write sec x tan y whole square, right, plus tan x sec y whole square plus 2ab, that is 2 sec x tan y into tan x sec y, right. So clearly see that this particular term and this particular term both are same, because 2 here sec x into sec y, here sec x sec y, tan x tan x tan y tan y. So clearly these two terms are equal. So what happens, this is equal to, here see that sec x sec y whole square, that means ab whole square can be written as a square b square, that's why I can write this is sec square x sec square y right, plus tan square x tan square y plus 2 sec x sec y tan x tan y. Then here minus is present and that minus will be multiplied to each and every term, right? So clearly this will be sec square x tan square y, right? This whole square will be sec square x into tan square y, and minus is present outside the bracket. While opening the bracket, this minus will multiply to each and every term within the bracket, right? That's why this will be minus. Similarly, minus multiplied to plus, again it is minus. This is a tan square x sec square y minus, again minus multiplied to plus, clearly it is minus. This is a 2 sec x sec y tan x tan y. I will write in this manner, right? Tan y, right? So that this particular whole term and this whole term will cancel out. That means this whole term, this one, right? This is this one as well as this one. These whole term will cancel out. So what is the remaining here? The remaining terms are, see that, sec square x sec square x into sec square y plus tan square x into tan square y minus sec square x tan square y minus tan square x sec square y, tan square x sec square y. So see that this is the first term. Here we have sec square x sec square y, right? So from first term and from third term I will take sec square x common, right? So I will take sec square x common, right? So sec square x, if I will take sec square x common, then clearly in this particular term what is remaining? Sec square y, and in this particular term tan square y will be remaining, right? Similarly, from this term and this term, that is second term and fourth term, I will take minus tan square x as common, right? That means I have taken what? Minus tan square x common. So from the fourth term, what is remaining? Sec square y is remaining minus, in this particular term, tan square y is remaining. Tan square x multiplied to sec square y minus tan square y, right? So in this particular term, see here again, this particular term and this particular term is common. In both the term, this one and this one is common. Otherwise you can apply the formula sec square theta minus tan square theta is equal to 1. Directly you will put, right? This is sec square x multiplied to 1 minus, this is tan square x multiplied to 1. What is the reason? Reason is since sec square theta minus tan square theta is equal to 1. So here we got sec square x minus tan square x. Again clearly as per the formula this is 1. So clearly we got this expression is equal to 1, which is nothing but the right hand side. So just I have used a plus b whole square formula over here. Otherwise you can also apply a plus b into a minus b formula, and we have to do some simplification to get the answer, right? Here I have used a plus b whole square formula only, right? And I have taken something common so that to get this particular formula, and in that formula we have to substitute 1. That is the trick, right? So similarly we will go for question number 9, right? See here in the question number 9, we have to show that cos x divided by 1 minus sin x is equal to 1 plus cos x plus sin x divided by 1 plus cos x minus sin x. So here I will take the right hand side and I will show that this right hand is equal to cos x divided by 1 minus sin x. Next we will go for question number 9. In this particular question we have to show that cos x divided by 1 minus sin x is equal to 1 plus cos x plus sin x divided by 1 plus cos x minus sin x, right? So in this particular question I will consider the right hand side and I have to show that this particular expression, that is cos x by 1 minus sin x. So at first I will consider the right hand side, right? So in the right hand side we have 1 plus cos x plus sin x divided by 1 plus cos x minus sin x, right? So to evaluate this particular expression, here we have to rationalize this denominator. That means we have to multiply opposite sign of this particular expression, that means 1 plus cos x plus sin x, right, in the numerator as well as in the denominator, right? So I will multiply 1 plus cos x plus sin x with 1 plus cos x plus sin x, right, divided by here 1 plus cos x, this is minus sin x, right? Here this is 1 plus cos x plus sin x, right? So now we will multiply this one. So clearly this is we will multiply directly, otherwise you can take this is whole square 1 plus cos x plus sin x whole square, this will be taken as a and this will be taken as b, right? Otherwise directly we can multiply, right? So this will become 1 plus cos x plus sin x whole square divided by, here I will consider this is a, this is b, so a minus b multiply to a plus b, so clearly this is 1 plus cos x whole square minus sin square x, right? So see here, so here I will apply a plus b plus c whole square you can apply, but here I will apply a plus b whole square. I will consider 1 plus cos x as a, right? So in the numerator I will take, this is 1 plus cos x whole square plus this is sin square x plus 2 sin x multiplied to 1 plus cos x, right? Whole divided by, here I will apply a plus b whole square formula, right? So this is 1 plus cos square x plus 2 cos x minus sin square x, right? Square x. Now, so this one equal to, here I will apply a plus b whole square formula, that is 1 plus cos square x plus 2 cos x plus, here is sin square x plus 2 sin x multiplied to 1 plus cos x divided by, here I will write 1 minus sin square x, 1 minus sin square x plus cos square x plus 2 cos x, right? See that clearly cos square x plus sin square x again 1, right? So I will put 1 plus 1 plus 2 cos x plus, this is 2 sin x multiplied to 1 plus cos x divided by, here is cos square x plus cos square x plus 2 cos x, right? So this one equal to, see here, this is 2 plus 2 cos x plus 2 sin x multiplied to 1 plus cos x divided by, this is 2 cos square x, right, plus 2 cos x. So clearly I will take 2 common, so this will be 2 multiplied to 1 plus cos x plus, this is 2 sin x multiplied to 1 plus cos x whole divided by, this is, here I will take 2 cos x common, right? So this will become what? Cos x plus 1, right? So I will take 2 into 1 plus cos x as common, right? So what is remaining? The remaining is 1 plus sin x divided by, this is 2 cos x multiplied to 1 plus cos x. So see here, this 2 will cancel, right? This 1 plus cos x also cancel out. So what is remaining? So here we got 1 plus sin x by cos x. But our requirement is cos x by 1 minus sin x. So here what we have to do? We have to multiply 1 minus sin x to the numerator as well as denominator, right? So this is equal to 1 plus sin x multiplied to 1 minus sin x divided by cos x multiplied to 1 minus sin x. See that in the numerator we have a plus b into a minus b, so clearly a square minus b square, that is 1 minus sin square x by cos x into 1 minus sin x. So 1 minus sin square x is equal to how much? Cos square x divided by, this is cos x multiplied to 1 minus sin x. So 1 cos x will cancel out, so remaining is cos x by 1 minus sin x. This is our RHS. So we can easily prove this one. So here we have to do the rationalization to the denominator. That means we have to multiply 1 plus cos x plus sin x to the numerator as well as denominator. Otherwise you can also multiply 1 minus cos x minus sin x in the numerator and denominator. Then multiply and you can easily find out the result, that is cos x divided by 1 minus sin x. So this is the proof of question number 9. Next we will go for question number 10. So in the question number 10, what is given? Tan cube x divided by 1 plus tan square x plus cot cube x divided by 1 plus cot square x is equal to 1 minus 2 sin square x cos square x divided by sin x into cos x. See here, in the left hand side it is given in the form of tan cot and in the right hand side it is given in the form of sin cos. So at first we will convert everything to the form of sin cos, right? So now we will go for question number 10, right? So I will consider left hand side. Here what is given? Tan cube x divided by one plus tan square x plus cot cube x divided by plus cot square x, right? So what is a tan cube x? Clearly it is sin cube x by cos cube x whole divided by this is equal to 1 plus sin square x by cos square x. Here 1 plus tan square x is present, otherwise we can directly put the formula over here. That is very easy, right? Clearly we can write, first of all we will put the formula over here, that is 1 plus tan square theta. Since we have the formula, see that sec square theta minus tan square theta is equal to 1. So clearly sec square 1 plus tan square theta is equal to sec square theta. Directly we will put. After that we will change into the sin cos, right? Similarly again we have the formula cosec square theta minus cot square theta is equal to 1. So clearly we have these two formula. Directly I will write, this is tan cube x divided by 1 plus tan square x is equal to sec square x, right? Plus this is equal to cot cube x divided by 1 plus cot square x. From this formula this is cosec square x, right? After that I will put the we will convert this expression in the form of sin cos, so that we will get in the form of sin cos, right? So this is sin cube x divided by cos cube x whole by this is sec square x. Otherwise directly you can write this is 1 by cos square x, right? This is first term, right? Plus here this is cos cube x by sin cube x whole by cos x square, that is 1 by sin square x, right? This is the second term, right? So this is equal to, what happens, this cos square will go to the numerator, so clearly here we will cancel this one, so this will become like this, sin cube x divided by cos cube x multiplied to cos square x, right? Then plus this is equal to plus cos cube x by sin cube x multiplied to sin square x. So we have sin cube x by how much, cos x, because here cos square x is present, here cos cube x is present, so cos square x cancel out, remaining is cos x, right? Here cos cube x divided by sin x, and this is equal to, here I will take LCM. So what is the LCM here? LCM is sin x into cos x, right? So clearly we will divide this one by cos x, so clearly we will get sin x, and that sin x multiplied to the numerator, that is sin 4th x plus this will be cos 4th x, right? After that I can write this one as sin square x whole square plus cos square x whole square, right? Divided by sin x into cos x, right? Here we have to apply a square plus b square formula. So what is our requirement? 1 minus 2 sin square x into cos square x. So we have the formula a square plus b square is equal to a plus b whole square minus 2ab. So clearly what is a? A is sin square x, b is cos square x, right? So sin square x plus cos square x whole square, that is a plus b whole square minus 2ab, that is 2 sin square x into cos square x, right? Divided by sin x into cos x to cos x. So clearly we know the formula, sin square x plus cos square x is equal to how much? 1. So clearly this is 1. 1 square is equal to how much? 1 only. Otherwise you write 1 square minus 2 sin square x into cos square x divided by sin x into cos x. So clearly this is equal to 1 minus 2 sin square x into cos square x divided by sin x into cos x. This is nothing but the RHS. See here, what we did, we have applied these two formula, that is sec square theta minus tan square theta is equal to 1. From this, sec square theta is equal to 1 plus tan square theta. So in the place of 1 plus tan square theta, I have written sec square theta. In the place of 1 plus cot square theta, from this formula, cosec square theta equal to 1 plus cot square theta. So clearly this is cosec square theta. After that, I have converted these terms in the form of sin cos. So clearly we got this one. After that, here cos square x cancel out, here sin square x cancel out. So this is the remaining sin cube x by cos x. Here what is the LCM, that is sin x into cos x, and in the numerator we got sin 4th x plus cos 4th x. Here I have applied a square plus b square formula and I got the result, that is 1 minus 2 sin square x into cos square x divided by sin x into cos x. So this is all about the question number 8, 9, 10. So yesterday I gave 10 questions, and from that most of the students have doubts, that is from question number 4 to 10, and here I have explained almost all the questions, that is from question number 4 to 10. Hope you have understood. Thank you.